This is CPM Precalculus, Chapter 1, number 73. So here we're given f of x is equal to x squared plus x. And also, g of x is equal to x plus 1. Okay? We're asked to find then part A, g of f of x. Okay, so when we're looking at the composition of multiple functions, so the input of this function is one of another function, we take this and we look at just the inside first. Okay, so leave g on the outside, and let's substitute in for f of x the expression of f of x. So that's x squared plus x. Now this now becomes g of, with the argument, the input, instead of x squared plus x. So we just plug in everywhere we see an x in the equation, x squared plus x. So that's the same as x squared plus x, right, plus 1. And this is the answer. So we're done with part A. Part B asks us, what is f of g of x? Okay, so this is similar, but now instead we leave f on the outside and just substitute g of x for x plus 1. Okay, now this is f of x with the argument no longer being x, but x plus 1. So everywhere we see an x, we have to substitute x plus 1. So we have x plus 1 squared, right, from the x squared, plus x plus 1. Okay? So this we know is the same as x plus 1 times x plus 1, right? The x plus 1 squared plus x plus 1. This we can multiply and distribute x plus 1 times x plus 1. You can use the box method or FOIL or any method you prefer. That's equal to x squared plus 2x plus 1. And we still have plus x plus 1 over here. And then combine like terms. So x squared plus 3x plus 1. No, plus 2. Right? 1 plus 1 is 2. So this is f of g of x. Okay, let me box my answers for A and B. Okay, part C. C is for what values of x will f of g of x equal to 1? Well, what is f of g of x? We already did that right here, so let me just plug this in to there. So on the left we have x squared plus 3x plus 2, and where is this equal to 1? So where is this true means solve for x for where this is true. So remember, when we're solving for x, we want to set it equal to 0 first, so let's subtract 1. We get x squared plus 3x plus 1 equals to 0, right? And now what can we do? We can use different methods. We can use, let's see, we can use our quadratic formula, yes, with a equals to 1, b equals to 3, and c equals to 1. So let's try that first. Well, can we factor? I like to factor whenever I can because that's a little faster than the quadratic formula. So factoring would say some terms equal to another, right? On the left equals to 0 on the right. And that would require us to multiply two numbers to get 1 and add two numbers to get 3. So multiplying two numbers to get 1, well, if we're not going to look at fractions, it's just 1 and 1. And can we add them to get 3? No. So let's not do this method. Because we can't use this method with just whole numbers, and let's use the quadratic formula instead, because that way always works. So we get x equals to negative b, which is negative 3, plus or minus square root of b squared, which is 3 squared, minus 4ac, which is 4 times 1 times 1, all over 2a, which is 2 times 1. Let's simplify that. 3 squared is 9 minus 4 over 2, right? Let's go ahead and do this. We get that's equal to negative 3 plus or minus square root of 5 divided by 2. Okay. So here we have x. So x equals to this, right? So let's split it up. That's the same as negative 3 plus square root of 5 over 2, or negative 3 minus square root of 5 over 2. Okay, so these are the two possible values of x. We can just leave them like this, or we can plug them into our calculators. So I have my calculator right here. I'm using the TI-83, and I plug in negative 3 plus square root of 5 divided by 2, and I get negative 0.3819660113. So let me round that to 3 decimal places, so 3819, so that 9 makes the 1 a 2. And I'm going to change this to approximately, because I'm approximating. Or, now let me say negative 3 minus square root of 5, and then divide that by 2, I get negative 2.618033989. So 6.180, that 0 leaves this as an 8. Okay, so x is going to equal this right here, right? This number, or approximately negative 0.0382, or negative 2.618. Alright, so this ends Precalculus Chapter 1, number 73.